Alright, so we want to do 12.6 number 23. Says we've got f of x and y is xy over, what's x squared plus y squared? What's that good for?
1 on the circle.
Yeah, it's 1 on the unit circle. That's a radius squared, right? Okay, so that's something to do with how far out a point is, right? And then we've got when x and y aren't 0, 0. The heck is that about?
All but the origin.
Discontinuity.
Yeah, it's just saying that the domain for that piece, right, is everywhere not the origin. Did I know that already?
Yeah.
Oh yeah, it had to be everywhere not the origin, right? Because that was the native domain of this piece. So what's this other piecewise piece? It's 0 when
When x, y is 0.
so it's 0 at the origin. What's the good of that?
It continues. It makes the function continuous.
Hopefully.
I would, yeah, hope so, right? Maybe it makes the function continuous.
Yeah.
Okay, so part A is something about show that f of x and 0 and f of 0 and y are continuous. So let me just fill in what's f of x and 0. Here, I'll fill in the second part.
Well, it's just 0 on the top.
Oh, and it's also 0 on the top, right?
Yeah.
You guys all see that?
The difference is the bottom one continues.
So it's 0, right? When x isn't 0. You guys see that? And then it's 0 again when x is 0. So what is this function?
It's just continuous. It's a line.
Yeah, it's the 0 function, right? Okay, so I know along the x-axis, right, my function's 0. Along the y-axis, in piecewise mode, this thing is what?
0 over y squared.
0 over y squared when y is not 0, right? And 0 when y is 0. Okay, so similarly, right, that's 0. Okay, so being the 0 function, right, these are both continuous. I know that from Calc 1, right? In fact, they're differentiable and infinitely so, right? Bastards. Alright, so after I did part A, what did part B ask?
Show that the rays emanating from the origin are contained in contours of f.
Okay, so I'm supposed to show the rays are in the contours. Okay, what's a ray look like?
One straight part of a line.
Okay, so here's this guy, right? X and Y. A ray looks like this, right? What's the equation for a ray? Yeah, it's part of y equals mx. Did you say plus b?
Plus b.
You need the plus b?
No, you don't.
Specifically here, these are supposed to be rays from the origin, right? So I definitely want to keep the b out of things. Okay, so I'm just thinking, all right, this is y is mx, and if I want to make it a ray, right, I want to force m to be bigger than 0. Okay, so they want me to show that these are in the contours, right? How would I show that?
They all have the same function value.
Yeah, I just want to show that they're on the same level curve, right? So I should plug them into the function and see if I get the same number out. So I'm going to take a look at f of x and mx, right? And what do you get? On the top? Mx squared. Right, you get x times mx gives you mx squared. And on the bottom, x squared plus m squared x squared. So, what do you notice?
You get rid of x.
Yeah, you can slash e some x squareds, right? And get m over 1 plus m squared. Okay, there you go. That's a level curve, right?
It's a number.
You guys see that? Okay. So that shows the rays are contours, right? Or in the contours at least, right? Because the rays all give the same function value out. Okay. And C is
it continuous? Is f continuous at 0, 0?
okay. So how do I establish continuity? What do you need for a function to be continuous? Yeah, to be globally continuous, I need defined at all points. To be continuous somewhere, I need
A limit.
yeah, I need a limit, and I need it to be equal to close. So I need a limit at 0, 0, and in this case, I need it to be something specific. 0, y 0 in this case.
Comes in the origin.
Find the function value as 0 at 0, 0.
Yeah, perfect. I need the limit and the function value to agree, right? Like if that surface comes to some place and the defined function value is up here, it's not continuous there, right? It's got to jump. If the limit doesn't make sense, right, where I've got these two surfaces that come in, it's definitely not continuous, right? So I need the limit to exist and for it to be the function value. So I know what the function value is, it's 0. Is the limit 0? No? Yes? I don't know.
We've done the work to take the limit already.
Okay.
Well,
This will tell me the limit as I come in along y equals mx, right? So what's the limit of that? Like, give me an m that gives me something that's not 0. 1? Oh.
just give you 1 half.
Yeah, 1 just gives me 1/2, right? So what does that mean? That means the limit as x and mx, right? Really, x and x tend to 0, 0, right? Of my function is 1 over 1 plus 1 gives you 1/2. What good's that do you?
Doesn't show the function values in the limit.
Good. The function value and the limit aren't equal. So,
You need limit.
anybody? So the function value, right? The function value is 0. The limit along at least one line isn't 0.
Function not continuous.
Function can't be continuous.
Uh,
You guys see that? So, f continuous at 0, 0? Nope. You guys see that? They even give you a little picture in the book of some kind of folded little hanky looking thing,
Yeah,
right?
it's weird.
And that folded little hanky looking thing has a problem because it's got a really sharp fold at 0, 0. That's what we're seeing here. Right? When we came in along the line y equals x, we got to a height of 1/2. When we come in along either the x or the y axis, we get to height 0. Cool?